So now we have two special logarithmic functions. We have one with log base 10 and one with log base e. Log base 10 is called the common log function. It's just usually denoted as log of x. So if you see a log function with no base written, you assume it to be log base 10. So if there's no base written, we will assume that it's the common log. The log key on sometimes used is the common log function. This y equals log of x if and only if 10 to the y equals x. So if we're asked to evaluate this on our calculator, so here's my log function. So I'm going to type log 376 close parentheses, and then I'm going to hit enter. Let's do b. It's log 1.6 times, we'll do 10 caret key 7. Enter. And let's do the last one. Just a quick comment on this. Remember, this is log base 10. This is giving you the exponent for the answer. So this is telling you what exponent you'd have to raise 10 by to get 0.0075. In fact, we can verify that. If I take 10, caret key, go ahead and grab that exponent, hit enter, 0.075. Now the second type here is the natural log function. Log base e of x is called the natural log function. It's usually denoted as ln of x. Thus, if there is written ln x, we assume that it's the natural log function. The ln key on your certificate is the natural log function. Thus, y equals ln x if and only if e to the y equals x. So here's a few exercises for you to try on your calculator. Make sure you can do it on your calculator, particularly if you have a different type of calculator than this one. Most calculators nowadays, you type the ln key and then the number and hit enter. There's some of the older ones that you'll need to type 95 first and then hit the ln key, or then the number, hit the log key. So you'll just have to try that out. So let's do 0.08. And then ln of 4.5. Now, critically important, remember we said that the domain for the log functions has to be greater than 0. So if I try to take the log of 0, I'm going to get a domain error. Or if I try to take ln of -3, I'm going to get a domain error because those numbers are not in the domain of the function. So let's go back to our workbook. And go ahead and evaluate each of these expressions. Now, let's see if we can do this without a calculator. And here's what you have to remember. Log and exponential functions are inverse functions. So if I write this as log of 10 squared, here's a function composed with an inverse function. That is your x. 10 to the x, and then you're undoing it. It's asking what power do I have to raise 10 by to get 10 squared. So that power has to be 2. So that's just using the definition of a function with its inverse. Now, go ahead and do it on your calculator. Take log of 100. Notice it does give you 2. Let's try number 12. So I'm going to rewrite that as log Now that's the same thing as 1 over 1, 2, 3, 4, 0, so 10,000. That's the same thing as log of 1 over 10 to the fourth, which is the same thing as log of 10 to the negative 4. So that should be equal to negative 4, doing a function with its inverse. Again, try it out. Notice we get a negative 4. Again, here I'm doing a function with its inverse. Natural log of e to negative 3, that should just give me negative 3. And natural log of e to the 10, that just gives me 10. You can then verify it on your calculator. And then now we're going to use your calculator to find the approximate value, round your answer to 4 decimals, check your answer by using the exponential form. So when we do common log of 43, that gives us this exponent. And then we're going to check by taking 10 to that answer. Verify we get something very close to what we originally started with. So I'm going to do log of 200. It's common log. 2.3011. If we round that, I'm sorry, 10. I didn't see the 2 there. And then I'm just going to check if I take 10 to the power 2.3010, I should get something very close to 200. And I'm a little shy because of round-off error. Let's try number 16. So we're doing log 0.074. It's negative 1.1308 if we round that off. And let me just verify that. So I'm going to take 10, caret key, negative 1.1308. And yes, we get something very, very close to 0.074. Let's try number 18. We're going to take the ln of 200. So that's 5.2983. Now test it out. Since I did the ln, remember my base here is going to be e, so my check, I'm going to do second e, 5.2983. And again, I get something close to 200. So that checks. And let's try the last one here. We've got ln of 1.005. Ooh, that's tiny. So that's going to be approximately 0.00, well, I guess it's going to be 50, right? Let's check it. Yep. It's all very close to 1.005. All right, so let's go back to our handout. And let's talk about log functions and their graphs. Since logarithmic functions are inverse functions of exponential functions, then the graph of a logarithmic function and the graph of the exponential function should be symmetric to the line y equals x. So here's my exponential function when b is greater than 1. So that's going to be my log function, the graph of my log function when for b is greater than 1. And then here's my b to the x when my function here is, when my b here is between 0 and 1. So this would then be the inverse function, which would be log base b of x. Now notice again the domains here for both of these is the positive real numbers. The range is all real numbers. I have an x-intercept at 1, so 1 comma 0. There's no y-intercept. We're going to have some vertical asymptotes here at x equals 0 and here. Let's see, it's increasing here, decreasing here. It's 1 to 1. And then the points I'm going to keep track of are 1 over b comma negative 1, 1, 0, and b 1. So let's go ahead and try some workbook problems. So like problem number 20. It says graph y equals log base 3 of x. So I asked to plot 4 points in an asymptote. Okay, so they tell us to rewrite into an exponential form and select values for y first. Okay, so exponential form. Y would be my power, so this would be, my base here would be 3. My power would be y. And this is equal to argument, which should be x. So this is going to seem a little weird, but what I'm going to do is I'm going to pick values for my y. That's what they're telling me to do, negative 3, negative 2, negative 1, 0, 1, 2, and 3. Okay, so then 3 to the negative 3, that's going to be 1 over 27. 3 to negative 2 is 1/9. 3 to negative 1 is 1/3. 3 to 0 is 1. 3 to the first is 3. 3 to the second is 9. And 3 to the third, that's 27. So I'm just plugging this into here. It seems kind of backwards, I know, but it's what they want us to do. So let's plot these points. So I'll keep it's now x comma y. So x is extremely small, y is negative 3. So that's like way down here. Still very small, so that's maybe about here. Still really small, that's about here. Still small, about here. 3 comma 1. 9 comma 2. 27 comma 3. Okay. And then our vertical asymptote would be x equals 0. So I think if I remember correctly on the homework, you'll need to draw in that vertical asymptote and give it like 4 points to get able to plot it. So again, just kind of summarizing what we said in before. Looking at your two cases, was b greater than 0? We actually did also the case when b was in between 0 and 1. So let's look at an application. Use the formula pH equals negative log H3 positive. The variable pH represents the level of acidity or alkaline of a liquid on the pH scale, and H positive is the concentration of hydrogen ions in the solution. Determine the value of HP in moles for the following liquids given their pH values. Express your answers in scientific note with 3 significant digits. All right, there's a lot we need to unpack there. Okay, so they've given us this formula. First of all, notice the formula uses the common log. So that's the first thing. So, my pH is 2.3. That's equal to negative log of h positive. Now, what I want to do here, boy, they didn't give us enough room to do this, did they? That's okay. We'll make it work. So I'm going to call this part A here. So first I want to get the log by itself. So I'm going to divide by -1. And then I want to find out what my argument is. The way I do that, I need to change it into an exponential equation. Remember, this is the common log, so my base here is 10. This is going to be my power. -2.3. And that's what h positive has to be. All right, so let's put that in our calculator. Now, if you put that into the homework, it's going to stick out its tongue at you because it wants in scientific notation. So you'll need to convert this into scientific notation. You can do it by hand, slide the decimal point over 3 places. So that would be h positive equals 5.012 times 10 to the -3. Now, the other way is on this calculator, if you hit your mode key, notice the second line has norm for normal. The second one has SCI. That's for scientific notation. So when you hit the mode key, you're here. Hit your down arrow and then your right arrow until it's flashing over SCI and hit enter. Do second quit and then hit enter again. And there it's going to write into scientific notation for you. And they said 3 significant digits. So we got 1, 2, 3. So actually, we're going to write this as 5.01 times 10 to the -3rd. Okay. Now we're going to do the same thing for the milk. All right, so now I'm going to do 6.2 equals negative log of h positive. I'm going to divide by -1. And then rewrite it in exponential form. So it says h positive has to be equal, again, remember my base here is the common log is 10. That -6.2 is my exponent. Now, it should be easy now since I already have this thing in scientific notation. Go to 10 caret key, -6.2. Hit enter. And so that would be round off to 6.31 times 10 to the -7. So I put that down here. So let me just put it kind of approximate here, and then we're going to round to 3 significant digits. 1, 2, 3. There's our 3. And that'll be answer. Okay, before you exit out of the video, when you go back to do the rest of your problems, it's now always going to give your answer in scientific notation. So take a moment and click on mode. Move that cursor down so it's flashing over norm for normal. Hit enter. And then do second quit. And that will get you back into regular notation. So just make sure you do that.